Now, if you want to evaluate this integral, you see that it is a power of sine. It's a sine square there.
Hello.
First
Good
convert.
morning, sir.
Good morning. Govinda, why are you late? So the integration here is x sine square x. So you see a sine square, you convert that to power 1 by taking multiple angle formula. So you have integral x by 2, you write this as 2 sine square x dx. And now what you can do is you can write this as half of, you can take half out, it will x, and sine square x you can write this as 1 minus cos 2x dx. So now this is half, you separate, what do you get? Integral x dx you will get minus integral x cos 2x dx. Okay, and x dx, x dx, how will you evaluate? It is half of x square minus, now integral x cos 2x you have to integrate by parts, so which is a product of a algebraic function and a trigonometric function. So which one should I take as my first function? I will take the algebraic function as my first function, as my u integral v dx minus integral of the derivative of x into the integral of cos 2x dx, and whole thing, this also is within dx. So this is half x square minus, now integral cos 2x is sine 2x by 2. So this is x by 2 sine 2x minus integral of derivative of x, which is 1, into integral of cos 2x is half sine 2x dx. So that is done. Half of half x square minus x by 2 sine 2x minus half integral sine 2x dx. So this is half of half x square minus x by 2 sine 2x, and integral sine 2x is minus cos 2x by 2. So you have, this will become a plus 1/4 cos 2x, and you add a constant of integration. Any problem with any step?
No, sir.
No, sir.
Now we have to evaluate this integral cos root x dx. Okay. Now remember, whenever you have to integrate, if you see there is no product here, you see only one function, right? Which is cos. Okay. So whenever you see that there is only one function, the technique here is to express it as a product of two functions as 1 into cos root x. One is also a function, constant function. You can write this as integral 1 cos 2x. Now this is u into v. One is an algebraic function, cos root x is a trigonometric function. Okay. Now the problem here is that you can treat one as an exponential function also. In fact, whenever you get a product with one, you treat it as the second function. Okay, whenever you get a product with one, you treat it as a second function. Okay, why? Because if you differentiate one, you will get a 0 uh, in the second part of the integral. So what you do here is you treat cos root x as the first function. Integral 1 dx, or simply dx you can write. Okay, minus integral of the derivative of the first. Derivative of the first is d dx of cos root x into the integral of the second. Second function is 1, so you can simply write integral dx and whole thing dx. So now this is x cos root x minus integral of, now derivative of cos root x is how much? Dx of cos x is minus sin x, right? So minus sin root x into the ddx of root x is 1 by 2 root x into integral of this is simply x, okay, into dx. Okay, so that is something that you can do here. In the next step, x cos root x minus, now what you can do here is this minus and minus will become plus, and you can take half out of the integration, and you will write sine root x divided by root x, and you can write x as root x into root x dx. Next, x cos root x plus, now here 1 root x will cancel off. You simply get a half integral x sine root x dx. In fact, root x sine root x dx. Now again you have to integrate root x sine root x by parts. So x cos root x plus half. Here you treat root x as your, because root x is an algebraic function, you treat it as your first function. So root x, or you can treat this one as your second function actually, because you cannot integrate sine root x. So you treat this as your first function, sine root x integral root x dx minus integral of derivative of sine root x is um, cos root x by 2 root x, okay, into the integral of root x dx, and this whole thing, a curly bracket, dx. Okay, so this is x cos root x plus half. Now how do you integrate this? Root x to the power of half is x to the power of half plus 1 by half plus 1, which is 2/3 x to the power of 3 by 2 sine root x. Okay, next minus um, integral cos root x by 2 root x to the power root x here is integral root x is 2/3 x to the power of 3 by 2, isn't it? Yes.
Yes, sir. Yes, sir.
So what are we getting here? Hmm. Instead of doing the last way, what you do here is you multiply the numerator and denominator by root x. That will make your work a little easier. Okay, you multiply the numerator and denominator by root x. Now what you do is let t is equal to, you know that the derivative of root x is 1 by 2 root x. So you put t is equal to root x. So what do you get? Dt dx is equal to 1 by 2 root x. That means what is dt? Dt is dx by 2 root x, or you can write 2 dt is equal to dx by root x, right? Now you see you have a dx by root x here. This becomes your dt. Okay. So therefore, what does I become? I becomes integral t cos t, and dx by x is 2 dt. So this becomes twice integral t dt, t cos t dt. Now t cos t dt can be integrated by parts twice. Take t as your first function into the integral of the second minus integral of the derivative of the first d dt of t into the integral of the second, right? Now you understood? T sin t minus integral of d dt of t is 1 and integral cos t is sin t dt, which is twice t sin t, and integral sin t is minus integral of sin is minus cos, so it becomes plus cos t plus c. Now you put back the value of t. T will become, t we have taken root x, so this is root x sin root x plus cos root x. So if we substitute t is equal to root x, the integral becomes much more easier. Any questions here? Govinda, any questions?
No, sir.
Yes, I couldn't hear anything. Govinda, you are there? You have got lots of excuses nowadays. Next problem. Given integration is x log x dx. X log x dx. How do you integrate x log x? You see, it is a product of two functions. One is an algebraic function, other is a logarithmic function. So which one will be your first function? The logarithmic function. According to the Eilert rule, logarithmic function will be my first function. So I write this as log x integral x dx minus integral of the derivative of log x into the integral of dx. Whole thing dx. Okay. So now this is half of x square, integral x dx is half x square into log x minus integral of derivative of log x is 1 by x. Integral x is half x square dx is equal to, now this x, 1x, and this x here will cancel. You're simply getting half of x square log x minus half integral x dx, which is half x square log x minus half of integral x dx is half x square plus c, which is half of x square log x minus 1/4 x square plus c. Okay, so that is integral x dx. Let's do the next one. So how will you integrate only log x? How will you integrate only log x? See, this is only one function, right? So you can write this as a product of two functions as 1 into log x dx, right? Now, which one should you take as your first function? Log x should be your first function, because if you take log x as your second function, then you'll have to integrate log x, which is actually the question. Okay, so what you do is you take log x as your first function, 1 as your second function, integral dx minus integral of the derivative of log x into the integral of 1 dx whole thing dx. So this is integral log x integral dx is simply x. So x log x minus integral ddx of log x is 1 by x into integral dx is simply x dx. Okay, so this x and this x cancels. We simply get x log x minus integral dx, which is x log x minus x. And if you take x common, you get x into log x minus 1, and you can add a constant of integration at the last. This is how you integrate log x. Next integration is, how will you evaluate a single function, inverse circular function? Let us say how to integrate sine inverse x. How will you integrate sine inverse x dx? Again, this is just like log x. You take sine inverse x as your first function. So sine inverse x integral, you can write this as obviously integral 1 into sine inverse x dx. If you take sine inverse x as your first function, 1 becomes your second function minus integral of the derivative of sine inverse x into the integration of dx whole thing dx. So now this becomes x sine inverse x minus integral of the derivative of sine inverse x is 1 by root 1 minus x square, and the integral of dx is x dx. So this simply takes the form x sine inverse x minus integral x by root 1 minus x square. Now the problem is how to integrate this, right? X by root 1 minus x square, how to integrate? So what you do is, any idea how to integrate this? Can you tell me? Let us take this as I1. Therefore I1 here is integral x dx by root 1 minus x square. Yes, tell me, any idea how to integrate this? So now if you want to integrate this this one x dx by x by root 1 minus x square, you know that the derivative of 1 minus x square is minus 2x, right? So what you try to do here is you try to take a 2x in the numerator. Write this as 2x dx by root 1 minus x square. Okay, Now what you do here is you put t is equal to 1 minus x square. That means you get dt dx is equal to minus 2x. That means dt you get as minus 2x dx. That means 2x dx you get as minus dt. Therefore, I1 is equal to integral 2x dx is minus dt, so you put minus dt, and you have taken 1 minus x square as t, so this becomes root t. So this becomes minus integral t to the power of minus half dt minus t to the power of minus half plus 1 by minus half plus 1. So this becomes minus t to the power of half by half plus c. This simply becomes minus 2 root t plus c. Now put back the value. Minus 2, value of t is 1 minus x square plus c. So therefore, you're getting I1 as this. Therefore, what is I? I is, what had we taken I to be? We had taken I to be x sin inverse x minus I1. X sin inverse x minus I1. X sin inverse x minus I1. I1 is minus 2 root 1 minus x square. And you can give another constant of integration. So this becomes x sin inverse x plus 2 root 1 minus x square plus k. That is your answer. How to evaluate sin inverse x? Okay. So logarithmic function is done, and inverse function is done. Trigonometric function, product of x and x, product of an algebraic function and a trigonometric function, product of an algebraic function and logarithmic function we have done. Okay, let's take a product of uh, an algebraic function and an inverse function. The last problem for today. X tan inverse x
Okay, sir.
dx. So this is again, which one should I take as my first function? X should be my first function. Ta- Sorry, tan inverse x should be my first function. So tan inverse x integral x dx minus integral of the derivative of tan inverse x into the integral of full thing dx. So this is half of x square tan inverse x minus integration of ddx tan inverse x is 1 by 1 plus x square, and x dx is half of x square dx. So you can rewrite this as half of x square tan inverse x minus, you can take this half out and write this as integral x square by 1 plus x square dx. Now the question is how to evaluate x square by 1 plus x square. So half x square tan inverse x minus half integral x square, you write this as 1 plus x square in the numerator, and since you have added an extra 1, you subtract 1. The numerator you can write as 1 plus x square minus 1 plus x square dx. This is now half x square tan inverse x minus half integral. Now if we separate this, you simply get 1 minus 1 by 1 plus x square dx. So this is half x square tan inverse x minus half integral dx plus half integral dx by 1 plus x square is equal to half x square tan inverse x minus half integral dx is simply x plus half and integral dx by 1 plus x square is tan inverse x plus c. And you can take all the half common and you can express this in better form as half of x square tan inverse x minus x plus tan inverse x plus c. That is your answer. Okay, I stop here for today.